April 16, 2026, Ukraine. Drones and missiles filled the sky. 703 targets total, including ballistic missiles. 667 were shot down. That's nearly 95%. Good enough or not?
Our partners see what we're doing, but they don't understand how we're doing it.
When Iran struck Israel and American bases, the 5th Fleet headquarters was on fire on day 1. That happened because the air defense system was overwhelmed and ran out of ammunition. But Ukraine has been repelling attacks like that every single day for over 4 years, without better interceptor missiles. So what's the secret? AI-powered acoustic sensors? Next-gen drone warfare? In 14 minutes, we're breaking down Ukraine's air defense system layer by layer, because every single layer matters. And then we'll find out why neither the US nor Israel can copy what Ukraine has built. So, Layer 1, Launch Detection. Space-based intelligence and human agent networks track missile deliveries to airfields, aircraft refueling, and bomber preparation. That's the primary indicator that a missile strike is being planned. All of that information flows into a central command post, and it's not an office in downtown Kyiv.
This is a mobile command post. We're constantly on the move, including the Air Force commander himself, because the enemy is hunting for the command center to destroy it.
NATO satellites also watch harbors, spotting the arrival of special cranes and transporters carrying long missile containers at the docks. When missile frigates or Varshavyanka-class submarines, which are also capable of launching missiles, put out to sea, they're tracked by AWACS aircraft, NATO Global Hawk UAVs, and signals intelligence assets. But almost every combined attack begins with Shahed launches, because they fly slower than missiles.
Massed combined strikes, that's always very hard and very intense.
Fixed kamikaze drone launch sites are under constant satellite and agent surveillance. During launches, Russians also make heavy use of standard pickup trucks, but concentrations of that kind of equipment are hard to hide. That's why Ukrainian defense forces learn about Shahed launches in real time.
Shahed's incoming, first wave.
But how do the Ukrainians figure out their numbers and routes? Before we move on to the next layer of Ukraine's air defense,
you should subscribe to the Weapons of Victory channel right now. It's an order.
Yeah, this one is most likely heading for Poltava. Distance 18 kilometers. Altitude 1,100 meters.
Layer 2. Target detection using radar and acoustic networks. Zvuk, Sky Fortress, and Fennec. This type of air defense is one of the most striking innovations of this war. Here's how this uniquely Ukrainian system works. Across the entire country, thousands of specialized sensitive microphones with microcomputers are mounted on cell towers, rooftops, and utility poles. The sounds of the surrounding environment are processed by dedicated software. The artificial intelligence is trained to filter out wind, rain, vehicles, and barking dogs. It analyzes and separates out matches with the acoustic signatures of cruise missiles, aircraft, and drones. The specific engine sound of a Shahed is recognized at a distance of several kilometers. The AI processes those sounds and plots the drone's route in real time on a digital map.
9531 heading toward Chernihiv, task for mobile fire group, locate and destroy.
And then a mobile fire group appears right in the kamikaze's path. That's Layer 3. The primary weapons of Ukrainian mobile fire groups are heavy machine guns, anti-aircraft guns, and sometimes man-pads. A single Stinger shot can cost up to $500,000. Even the simpler alternative, the Igla, costs more than a Shahed itself, up to $80,000. So the machine gun is the main tool of these groups. The gunner has a few seconds to bring down the target. That takes real training.
This is a simulator with a Browning M2 machine gun replica, caliber 12.7 millimeters. First, the shooter locates the target on the sphere, then points the gun toward the target, finds the target marker through the thermal optic, and begins engaging.
You can watch these groups in action on our channel, but the main challenge for the crews is finding the drone in a night sky. Russians launch drones both at ultra-low altitudes and push them up to 4,000 meters to put them out of reach of small arms. And that's when self-propelled Gepard AA guns and Mobile Avenger air defense systems enter the fight. The German Gepard has its own radar, so it can operate autonomously. A short burst from its twin 35mm Oerlikon autocannons is enough to destroy a single Shahed. The Avenger system has no onboard radar of its own, but it can receive targeting data from external sources. Once it gets precise coordinates, the gunner instantly acquires the target through thermal or optical sights and opens fire with Stinger missiles. But that's a last resort, because as we said, the cost of Stinger missiles forces Ukrainians to save them for cruise missile intercepts. So in 2026, Ukrainians introduced yet another method of fighting Shahed's anti-aircraft drones.
This is the Sting, a multi-rotor UAV. Its advantage is rapid launch, no launch pad required.
Ukraine is also using several other types, including American Merops interceptor drones. The speed of an interceptor drone allows it to chase down Shaheds and attack from the rear. It can operate at altitudes up to 5 kilometers and intercept not only kamikaze drones, but even high-altitude reconnaissance UAVs. That's why Russians send swarms of Shaheds over large bodies of water and sea, where mobile fire group crews, short-range SAMs, and anti-aircraft drone operators can't operate. And then the fighters go up. That's Layer 4. Both MiG-29s and Su-27s are up there alongside Mirage 2000s and F-16. And as you'd expect, cost matters. The cheapest weapon on a fighter is the aircraft cannon, 20 millimeters and up. Cannon rounds cost next to nothing compared to any missile. But shooting down a Shahed with a cannon is high-level flying. Literally. The effective range of aircraft cannons is only about 1 kilometer. When the rounds hit a Shahed, its 50-kilogram warhead detonates right in front of the aircraft. The pilot risks flying straight into a debris cloud. So for high-volume Shahed intercepts in 2026, Ukraine's Air Force started using cheap APKWS-2 guided rockets. This isn't a missile built from scratch. It's an upgrade kit for the unguided Hydra 70 rocket, adding a folding fin assembly and a laser seeker head. A single F-16 can carry up to 28 of them at once. That turns it into a true mass hunter, capable of destroying dozens of drones in a single sortie.
Ukrainian F-16s have already crossed the 1,000 mark for aerial targets destroyed.
Ukrainians also use light aircraft and helicopters with a door gunner on board. Their slower speed makes it safer to shoot down Shaheds without risking the aircraft. But the real next-gen drone warfare concept, a fixed-wing aircraft used as a launch platform for anti-aircraft drones, could be a total game-changer against Shaheds. Here's how it works. During a Shahed attack, an An-28 takes off. It doesn't need to chase a kamikaze with a machine gun or pull dangerous maneuvers. It spots the target, then drops an interceptor drone controlled by an operator on board. This is the first recorded example in history of aircraft being used as drone carrier platforms. Even in Ukraine, it's still rare. So some Russian Shaheds travel significant distances and reach critical infrastructure, loading down the air defense system.
Second wave inbound.
Around this time, the first Russian cruise missiles enter Ukrainian airspace. And that's when the medium and long-range air defense tiers enter the fight. Layer 5. NASAMS and IRIS-T, modern medium-range systems provided by Ukraine's allies, carry a heavy share of the workload. They reliably intercept low observable cruise missiles at ranges up to 20 kilometers.
My unit, without any exaggeration, is one of the best in the Air Force. We have destroyed 50 enemy targets on the most difficult axis.
The modernized Hawk handles its share just as well. Soviet S-300s and older Buk M1s, which were part of Ukraine's inventory before the war, are still effective thanks to powerful radar systems and large engagement zones. But due to a shortage of missiles, the role of the S-300 is shrinking. Ukraine is trying to find replacement missiles to keep those S-300 launchers in the fight. The Buk M1, on the other hand, has gotten a second life through the SAMP concept. It's a fascinating hybrid system. Ukrainians married an old Soviet SAM with American RIM-7 Sea Sparrow missiles. Soviet platform, Western guidance, range up to 30 kilometers, altitude up to 15 kilometers. Another pairing, a Soviet radar combined with a launcher carrying American AIM-9 M Sidewinder air-to-air missiles, all mounted on a truck platform. The radar finds the target, the Sidewinder kills it. Strictly speaking, at Layer 5, everyone is involved in repelling the attack. Fighters with air-to-air missiles fill gaps in the fixed radar coverage. If a missile punches through the large SAM systems and aviation, on its final approach, the Gepards and mobile manpad groups go back to work. Cruise missiles often fly very low, terrain hugging, which actually makes them vulnerable to ground ambushes. But the hardest problem for Ukraine is ballistic missiles. That's a different physics problem and a different level of danger. Conventional air defense systems are powerless against them. That's layer 6, the top tier. Only MIM-104 Patriot systems with PAC-3 missiles and SAMP/T systems with Aster-30 missiles play at this level. But even they don't guarantee 100% protection. What makes it so hard? First, because of shortages of modern systems, Ukrainians can only position Patriot and SAMP/T to protect the most critical targets.
We don't have enough PAC-3 missiles to be capable of repelling airstrikes.
Second, from the moment of launch to the point of impact in Kyiv, only a few minutes pass. A ballistic missile falls from the sky at a 90-degree angle at speeds up to 10,000 kilometers per hour. How do Ukrainians react in time? A satellite detects the ballistic missile within 10 seconds of launch. The Patriot's radar picks up the target. Another 10 seconds for the computer to calculate the trajectory. Then the operator confirms the intercept. That takes no more than 5 seconds. And 2 PAC-3 missiles, $4 million each, go up on the intercept with a few seconds between them.
Security always costs?
SAMP/Ts act faster because Aster-30 launches vertically upward, so there's no need to rotate the launcher toward the target. The missile navigates itself to the right direction. On its final approach, the Aster-30 activates its active seeker head, acquires the ballistic missile, and goes in for a direct hit. From the moment the ballistic missile launch is detected to the moment it's destroyed, 45 to 60 seconds. Imagine the pressure on those operators. But even the debris from a shot-down ballistic missile is still a weapon because it keeps falling at tremendous speed. That's exactly why ballistic missile attacks are the most intense challenge Ukraine's air defense faces. And yet Ukrainians have built a defense that holds against Russian combined attacks, with very solid numbers to show for it.
Just this past winter, my unit destroyed over 40 ballistic missiles. That number could have been higher if we'd had more ammunition.
Without the air defense shortage, Ukraine would be posting the highest interception numbers in the world. But why can't Israel or the US copy what Ukraine has done? On Israel. The problem is that there simply isn't enough physical space for deep layered defense, and the concentration of population, infrastructure, and economic assets within a limited area is so high that any hit or even falling debris causes enormous damage. So Israel built a layered and highly dense air defense system, but tailored specifically to its region. Instead of mobile fire groups, Israel has a fixed system capable of simultaneously shooting down thousands of cheap, unguided rockets.
To build a dome like that, you need a very, very large number of systems.
And they destroy Shaheds before they ever reach the country's borders. F-35s and F-16 fly out to intercept them in neighboring airspace and shoot them down with air-to-air missiles. Hard to even imagine what that costs. On the US, the American military simply does not plan around a scenario where an enemy mass strikes US cities with missiles or drones. And if kamikaze drones or cruise missiles were launched from Cuban territory, the US has a concept of layered coastal and air defense, where modern fighters and US Navy ships with the Aegis system play the central role. The idea is that the missiles and Shaheds never make it to American cities. Drop a comment below. Is American air defense sufficient? Or is there room for improvement? And in these playlists, you'll find more videos about the Western air defense systems fighting in Ukraine. Stay safe. Support Ukraine.